Okay, so as stated in yesterday's notes, there's different subcategories for your polygons, especially and in particular quadrilaterals. So we'll be spending a lot of time on this unit, and really the chapter itself is called quadrilaterals. It just kind of falls under the purview of polygons. So we're going to look at how to decide if something is a quadrilateral and if it is a parallelogram in the coordinate plane. But then also going from here, we'll just be talking a lot about quadrilaterals in general. So a parallelogram is a type of quadrilateral. And for something to be a parallelogram, the word right there in the front, parallel, kind of classifies it. So it has two pairs of opposite sides that are parallel. Remembering opposite means across from, not touching. And so, like, for example, this would be parallel to this, while this is parallel to this. So just like with the arcs or the tick marks for congruency, we increase the number of little arrows or carets on our sides to show parallelity, I guess maybe the plural. And also knowing that it is a quadrilateral. Okay, so given A, B, C, D, this is how you name a quad, just all four vertices, is a parallelogram. Find the following lengths in the coordinate plane. So remember, our length is our distance formula. So D is equal to x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Another option on these is if you have the graph, you can use Pythagorean's theorem, right? Because you can make right triangles going off of each side. Okay, so we're looking for the lengths here. So AB is this one. The length up, noticing these are counting by twos, so this, and starting at 1. So each of these is just 1 in between. So 1, 2, 1, 2, 3, 4 units. And across is 2 units. Or you can use the vertice of A, which is at 1, 1. And the vertex of B, which is at 3, 5. And plug those into your distance formula. So one way to do this, and we can do it two different ways, is to say, okay, 4 squared plus 2 squared is equal to c squared. We're finding the hypotenuse in this case. So we have 16 plus 4, so 20, square root both sides, and c is equal to the square root of 20, which is equal to, remember this breaks down into 4 and 5, 2 root 5. Okay. DC, same thing. So let's look at the coordinates here. This is 5, 1. This would be 7, 5. So if we use our distance formula this time, we have x1 minus x2. So I'm going to use my bigger numbers as my 1s. So 7 minus 5 squared plus my y's. So 5 minus 1 squared. And the square root of that will give me the distance of this line. So I have 2 squared plus 4 squared. These should really be in parentheses, just good habit. So you can kind of see where the similarities are starting to come in here. So we have 4 plus 16 is the square root of 20, which, as we saw above, is 2 root 5. So AB and DC are the same lengths. Anything that's on a straight line, you can just simply count. So this is 1, 2, 3, 4. So the length of AD is 4 units. Same with B, 1, 2, 3, 4 is 4 units. The other way to do that is subtract if you don't want to sit there and count all of them. So just subtract your distance horizontally. So we're going, horizontal distance is your x value from 7 to 3. So the absolute value of 7 minus 3 is the absolute value of 4, which is 4. So that's another way to do that. Okay. We can only count like this because the y value doesn't change. So, or you could do it if the x value doesn't change. All right, so when comparing opposite sides, right, hopefully you can see the opposite sides are congruent. Okay, so go ahead and practice this to see if you can find the distance, find the following lengths in this triangle, so, or in this parallelogram. Okay, so hopefully you have tried this on your own, but let's go through it. So BE, you noticed was right here. You can still make a right triangle out of this, right? So anywhere you can connect that right triangle, there's a 2 and there's a 1, you can do Pythagorean theorem. So finding the length of BE, you would do 2 squared plus 1 squared equals c squared. So 4 plus 1. And then square root both sides. So BE is equal to the square root of 5, right? That doesn't simplify or break down. You also have that option again to just use your distance formula. So this is 1, 2, 3, 4, 3, and this would be 5, 1. So you would do 5 minus 1. Sorry, back up. 5 minus 4 squared plus 1 minus 3 squared, and the square root of all of that. So 5 minus 4 is 1. 1 minus 3 is negative 2. So 1 plus 4 is the square root of 5. Okay. CE, you can see it's the right triangle for this one would be here. And so we have, again, 3 this way and 2 this way. All right, so you have to make a right triangle using your diagonal as the hypotenuse. So even if it's not inside of the shape, it's okay. So that would be 3 squared plus 2 squared equals c squared. So 9 plus 4. So square root of 13, again that doesn't reduce, is the length of AE. And then for CE, I'm going to do it the same. Oh, I did find CE. Sorry. Move all this over. For the other one, hopefully you can see AE is the same dimensions there. We have a 2, and we have a 3. So that's the same. Okay. So what we conclude about the diagonals, this is square root of 5. This is square root of 5. This was square root of 13. This is square root of 13. So hopefully what you can see from this is that the diagonals bisect each other, or they cut each other in half. Okay? So all of that has to do with coordinate planes, but also properties of parallelograms. So we saw that opposite sides are the same length. Opposite sides are also parallel. That's the definition of a parallelogram. And that the diagonals bisect each other every single time. So anytime you're given something is a parallelogram, you have all of those properties that you can use. So for this one, if MN is 2t, so this right here is 2t, and SP on this side is t plus 5, then find the length of MN. So because this is a parallelogram, based off of that property we just saw, these two opposite sides will be congruent, excuse me. So anytime, so we know that MN is congruent to SP, and anytime two things are congruent, we can set their expressions equal to each other. So 2t is equal to t plus 5. So t equals 5 minus t from both sides. All right? Well, MN then is 2 times 5, which is 10, which means that SP would also be 10 if you were solving that out. Then find the measure, if the measure of angle M, so this angle here is 45 degrees, then find the measure of MNP. So MNP is right here. All right, so this goes all the way back to our unit on parallel lines. Remember that these two lines here and here are parallel. So this is your transversal. So if this is 45, then those two angles here and here have a very specific relationship in that they are consecutive interior II doesn't work there. Consecutive interior angles, or same side interior angles, SSIA. So if you remember the relationship between same side interior angles, they are supplementary. So 45 plus the measure of angle MNP is 180 degrees. So the measure of angle MNP is equal to 135. This drawing obviously not to scale because this looks more obtuse than this. But that's how you would solve it out. Okay? So consecutive interior angles will be supplementary. Opposite angles in a parallelogram will be congruent. Okay, consecutive angles supplementary, opposite congruent, because these are consecutive angles as well. All right, so again, given this is a parallelogram, if AE is 3x minus 10, so here to here, and DE is x plus 12. Then we need to solve for x. Well, because it's a parallelogram, these are congruent. So 3x minus 10 is equal to x plus 12 minus x add 10. So 2x is equal to 22. And then x will equal 11. Right? You can plug that in and make sure you get the same length for both. Or if this asks you for AE, for example, you would do 3 times 11 minus 10. So 33 minus 10 is 23. Okay. For B, it says EC, so here to here is 5. Then find BC, which is from here to here. That is a really bad bracket. Okay. So if this is 5, CE is equal to BE, or congruent rather. So then this is also 5, which means the whole thing added together will be the whole thing. So 10. All right. Angles opposite in a parallelogram are across from each other. So opposite angles are supplementary, not, are congruent. Consecutive or same side angles are supplementary. Meaning they add to 180 degrees. Okay, so if I gave you this one, you should be able to then know this is 130. You could then figure out quickly that this would be 50 and this would be 50. Okay, so knowing what is the same, what adds to 180 will be important. That goes, again, all the way back to parallel lines and transversals. But other than that, that's it. So those are your parallelograms, and we're going to then break that down into specific types of parallelograms tomorrow. Have a good night.